Hey guys, how's it going? Today it's Friday, the 3rd, all right? And this video is gonna be focusing on going over the homework for lesson 4, and then going over lesson 5. Okay. Just want to say that I don't own, I'm not the owner or anything for New York Engage Eureka Math. This is the math that we use at Academy del Sol, 6th grade. Other than that, just doing these videos to help out my students. So I want to go over lesson 4 homework. Hopefully this answers some questions. Please follow the steps. Observe this video as close as possible, and hope this helps. All right. And after this, watch the video. It'll go over lesson 4s and 5. And hope you guys have a good weekend. All right. If you have any questions or anything, let me know. You can shoot me an email through Class Dojo or send me an email. All right. You can take a picture of what you're having trouble with. Let me know. I'll send you videos, guide you through this. All right. So for lesson 4, we're going to begin this going over the homework for lesson 4. So it's asking us for these four shapes, to calculate the area, figure out the scales that are drawn to scale, okay? So you have two options with this one. You can find the area of this triangle and then the area of this smaller triangle, add them together, and it'll give you the area of the entire triangle. Or the other method is you can add this base plus this base, okay, and that sum multiplied times the height, which is 8, then multiply it times 1/2, which will give you the area for that triangle. So I'm gonna write down the formula up here just to keep it in mind. Okay, what I'm gonna do is I'm gonna add the bases, and I'm gonna save some time. That means I'm gonna add the base of this triangle plus the base of the smaller triangle. So I'm gonna call it triangle 1 and triangle 2. So I'm going to add the base of the triangle 1, which is 15, and the base of triangle 2. So 15 plus 6, okay, which is 21. So this entire base right here, which I'm underlining at the moment, that's 21. So for base, I'm going to use area equals 21 times, and then the height is 8 times 1/2. All right. So my entire base for the entire triangle is 21. It's 15 plus 6, that gives me 21, times 8, which is my height, times the 1/2. And you like how Mr. Valencia, he turns these into fractions? Okay, now I can multiply going across, okay? 21 times 8, which is 168. Okay, so area equals 168 over 2. Okay, if I divide those, okay, if I divide 168 by 2, 2 goes into 16 8 times, which is 16. Bring down the 8, and 2 goes into 8 4 times, so it's 84. Okay, so the area for triangle 1 is area equals 84 inches squared. All right. If you want to pause and look at the steps, all right. And I'll jump to number 2 using the same formula again. Area equals base times height times 1/2. So my base for this one is 72 times my height, which is 21, times the 1/2. Okay, I'm going to turn these into fractions. Multiply across, and 72 times 21. 72 times 21. That's 2, 7. That's 4 and 14. 2, 7 plus 4 is 11. Carry the 1. So it's 50. So its area equals 1,512. I'm going to divide that by 2. Why divide that by 2? 1 times 1 is 1, and 1 times 2 is 2. Okay, so let's see. I'm gonna divide 1512 by 2. Okay, which is this one right here. 2 goes into 15 7 times, which is 14. It's 1 left. Bring down the 1. It goes in 5 times, which is 10. 5 times 2 is 10. 10 minus 11 minus 10 is 1. Bring down the 2. 2 goes into 12 6 times, which is 12. No remainder. So it's 756. So the area is 756 meters squared. All right. So that's the area for that one. Okay, if you want to pause the video again, look at the steps, go ahead. Let's focus on number 3. Okay, I'm gonna use this space right here. Area equals, so my base is this one. This is my base. Okay, this is my base, which is 75.8 times my height, which is this one, this dotted line, which is 29.2 times 1/2. Okay, I'm gonna make these into fractions, and I'm gonna multiply 75.8 times 29.2. Okay, a lot of you guys were sending me your work. Okay, and as I observe your work, okay, you guys, I noticed that some of you were small things where we needed to improve and work on our multiplication with decimals. All right, we need to improve on that. Okay, so I want to go over how to multiply this the correct way. Okay, so I'm going to multiply 75.8 times 29.2. Give me just 1 second. Okay, we're back. So I needed some white paper to do this. All right, so multiply 75.8 times 29.2. Show it in a piece of paper. Okay, 75.8 times 29.2, base times height. So let's multiply these, see what we get. 8 times 2 is 16. Carry the 1. 2 times 5 is 10. Plus 1 is 11. Carry the 1. 2 times 7 is 14. Plus 1 is 15. Now, begin at the tens place. 9 times 8 is 72. Carry the 7. 9 times 5 is 45. And 45 plus 7 is 52. And 9 times 7 is 63. Plus 5 is 68. Okay, now do the last one. Again, 2 times 8 is 16. Carry the 1. 2 times 5 is 10. Plus 1, 11. Carry the 1. 2 times 7 is 14, plus 1 is 15. We add, bring down the numbers. 6, 2 plus 1 is 3. 5 plus 2 is 8, plus 5 is 13. Carry the 1. 8 plus 1 is 9, plus 1, 10. 11. Carry the 1. 6 plus 5 is 11, plus 1, 12. Carry the 1. 1 plus 1 is 2. How many numbers are after the decimal? 1, 2. So these are your numbers. Okay. 2,213.36. Okay. So this right here, area equals 2,213.36. And I'm going to divide that by 2. Okay, so I'm going to divide this by 2. Okay, 2 goes into 2 one time, which is 2. 0, bring down the 2. 2 goes into 2 one time, which is 2. 0, bring down the 1. 2 does not go into 1, which is 0. Bring down the 3. 2 goes into 13 6 times, which is 12. There's 1 left. There's a decimal here. I'm also going to put it here. Bring down the 3. 2 goes into 13 6 times, which is 12. 1 left, and then bring down the 6. 2 goes into 16 8 times, which is 16. So that's our area right there. Okay. So area equals 1,106.68 kilometers squared. All right. That's the answer for that one. I'm going to zoom out right here. If you want to pause the video, these are the steps. Okay. We begin here. This is me showing more work. I needed more space to do that. All right. If you need to pause the video, pause it. If you need to rewind it, go ahead and do that. All right. I'm going to jump to problem 4. All right. And problem 4 was a bit of a challenge. All right. A bit of a challenge. Doable. Yes, of course. But it was a bit of a challenge. How many shapes did you have here? Okay. A lot of people were asking me about this one. This was not part of finding the area. Okay. The reason why they did this was to show you guys. Remember, I told you the dotted lines, okay, is just to show height, okay? So it was letting you know what the height of this triangle was, where the height of this triangle from here, from this dotted line to the very top, okay, is 7 meters, all right? It's 7 meters. That's all that it's letting us know. What we need to find is the area of these two triangles, that they're going to have the same area because they're equivalent. Okay, their height is 12 and their base is 5. If you see, that's the height of 12, the height of 12, base of 5, base of 5. And it's letting you know what's the units for this rectangle, which is letting us know that this is 19. So this should be 19. Okay, this side is 12 and this side is 12. All right, so we're going to find step by step, we're going to find the area of this entire shape that we have right here. Okay, and I'm going to start here from the bottom, all right? And I got to keep in mind that I have 1, 2, 3 triangles. So for the triangles, I need to use the formula base times height times 1/2. And for rectangles, I just need to use base times height, okay? So I'm going to call this triangle 1, okay? Triangle 2. And triangle 3. All right. So I'm going to begin with triangle 1. So whatever the area I get for triangle 1, it's going to be the same area for triangle 2 because they're the same triangle. It's just the reflection. All right. So I know that the base for both triangles, it doesn't matter which one. Okay. And even if I add them, which is going to save me some time, because imagine that these triangles look like this. If I get this left side, if I draw it, it kind of looks like that. Right? It kind of looks like that. And if I get this one and connect it with that one, it looks like that. And if I put them together, it looks like this. And I know that this is 5, and their height is 12, and they're all in meters, by the way. Okay. Well, if I add 5 plus 5, I know that the entire base of this triangle is 10 meters. So what I'm going to do is I'm going to multiply 10 by 12. Here's where I'm getting my 10. 5 plus 5. That makes 10. All right. And this is the height. They share the same height. So I'm going to do base, which is 10, times the height, which is right here. And I even do 12 times 1/2. Okay. Make that into fractions. Okay. And that equals 10 times 12 is 120, and 120 times 1 is 120, and 1 times 1 is 1, and 1 times 2 is 2. Okay, so now I'm going to divide 120 by 2, which is 60. And then I'm looking at the dimension units, meters squared. Okay, So I'm gonna draw a triangle there. So I'm gonna say that the area of these two triangles already combined. So that's letting you know, if you were to do it separately, the area of this triangle is 30 meters squared. The area of this triangle is 30 meters squared. And if you combine them or add them together, 30 plus 30 equals 60. But what I did is I combined them together. If you look at, here's the left side and here's the right side. I put the two triangles together. I found the area, which is 60. Now I want to find the area of the triangle on top. Okay, now I want to find the area of the triangle on top. All right. We know that the height is 7, which is letting me know right here. This is the base. This entire dotted line is the base, which is 7. So I know that my height is going to be 7. But what's the base, Mr. Valencia? Well, here's a big clue right here, okay? From here to here, basically from here, and I'm going to draw the points. From this point to this point, it's letting me know that it's 19 meters. But I still have this remaining area to find and this remaining area to find. Well, here's the spot right here. It's letting you know that from here to here is 19, right? If we add 5, 19 plus 5 is 24. And 24 plus 5 is 29. So this entire thing is 29. Or you could just add the 10 from the triangle. You can do 19 plus 10 is 29. Again, you begin here at 5. You can begin here at 5 as also. This is the other way. From here to here is 5. And then 5 plus 19, which is being shown here. 5 plus 19 is 24. And 24 plus 5 is 29. That's the other way to see it. All right, so we're gonna do base times height is 1/2, and we said that the entire base is 29 times the height, which is 7, so it's from this dotted line to up here, times 1/2. Okay, I'm gonna make these into fractions, multiply across. Let's see what's 29 times 7. 9 times 7 is 63. Carry the 6. And then 2 times 7 is 14. Plus 6 is 20. So it's 203 divided by 2. Why 2? 1 times 1 is 1 and 1 times 2 is 2. Now divide this. And see what we get. Okay. 2 goes into 2 one time. Bring down the 0. How many times did 2 go into 0? 0 times. Okay. Bring down the 3. 2 goes into 3 one time. I'm going to borrow. So I'm going to add decimals. Okay. You could also leave it, if you want, as a mixed number. And you could have said 1 and 1/2. Okay. But I'm just taking it a step further. And 2 goes into 10 5 times. Okay, so which is 101.5. So area equals, okay, for the bigger triangle, which I want to put a triangle here inside, saying triangle 3, which I think I wrote down in here just to guide you guys. The triangle 3 area for that one is 101.5 meters squared. Or you could have said, I'm going to write it here, or 101.5 meters squared. Whichever one you did out of these two, that works for me. All right? That definitely works for me. The reason why you can use both, all of the answers here are whole numbers. So if there would have been decimals, the answer should have been in decimal. If the answer would have been in mixed numbers, we would have seen the mixed numbers here. So we have whole numbers, you get the option to choose either of these two. All right, so the reason why I'm putting them in squares is because I'm gonna add them, and I'm actually gonna put them around a cloud too, so I remember that I need to add these to find the area of the entire shape. The last one I need to find is this one, which is base times height. So I'm gonna do 19 times 12. Okay, so base times height, which is the rectangle, 19 times 12. Okay, And that's going to let me know what's the area of the rectangle. 9 times 2 is 18. Carry the 1. 2 times 1 is 2, plus 1 is 3. 1 times 9 is 9. 1 times 1 is 1. Let's add them. 8, 9 plus 3 is 12. Carry the 1. 228. So the rectangle is 228 meters squared. Okay. Keep that in mind. Okay. Now I'm going to add them. I'm going to add the ones that are in bubble. So I'm going to do 60. I'm going to do, the reason why I like doing this, and it's easier for me to make it in decimal. It's easier to work in decimals when you're adding. That's my opinion. And 228. Okay. But it still works even using, so 0.5, bring this down. Okay. 8 plus 1 is 9. And 6 plus 2 is 8. And 3 plus 1 is 389. So the area, finally. Okay, the area is going to be 389.5. The area for this one is 389.5 or 0.5 meters squared. Okay, that's the area of the entire shape when you put it all together. Okay, we found the area of these two triangles. We find the area of this triangle, we find the area of the rectangle, you add all the areas together, and that's what you get, right? These are all the steps, okay? If you need to pause your video and look at them, pause them. I kind of represented it with the shape, okay? This is the area of both triangles put together, which is triangle 1 and 2, okay? This is the area of the bigger triangle, which is on top, triangle 3, and the last area is a area of the rectangle. And then here what I did, I added all 3 areas together, and it gave me this 389.5 or 0.5. All right, jumping to number 5. Okay, jumping to number 5 on the homework. So it's letting us know that it wants us to find the area, and once we find the area, it wants us to multiply that area by $2. So every square foot is worth $2. So if you have 1 square foot, 1 times $2 is $2. If you have 2 square feet, you multiply 2 times $2, which will be $4, and so on and so forth, right? So we're going to use the formula A equals base times height times 1/2. Okay, the base for this one is this one right here. Here's the triangle. Here's your base, which is 8 times, here's your height, the dotted line, which is 12 times 1/2. All right, put them in fractions so I can multiply across, and boom, 8 times 12 is 96 divided by 2. Okay, 2 divided by 96, 2 goes into 9 4 times, which is 8. 9 minus 8 is 1, bring down to 6, and 8 times 2 is 16. So the area of this triangle is 48 feet squared, but we're not finished yet, because now it wants us to multiply the area times $2 per square foot. So what it wants us to do is multiply 48 times $2. All right, and 48 times 2, or 48 times 2, or 8 times 2 is 16. Carry the 1. 2 times 4 is 8, plus 1 is 9. So your answer should have been $96. All right, be careful with that one. Yes, a lot of you found the area. That's amazing, but it was challenge you guys and telling you, because how much will the new cell cost? Every square foot costs $2. So we have 48 square feet times 2. That gives you your 96. All right, that is that. And we got one more page to finish, which is this one. All right. And it's asking us, Darnell and Donovan are both trying to calculate the area of the triangle, examine their calculations. So which one was correct? Which student calculated the area correct? Well, if you look at this one, okay, the base for this one is 12. Okay, the base for the triangle is 12. If I look at Darnell, he put that his base is 3. Donovan put that his base is 12. The base is 12, so Donovan so far is correct. And then the height is 4. Okay. Darnell did say that the height is 4. And Donovan also said that the height is 4. Okay. And if we actually figure this out, 12 times 4 is 48. And if we divide that by 2, it's 24. Okay. So Donovan was actually the correct one. Why is he correct? Donovan labeled correctly his base and height. All right. This is not the base. So this guy, that was his mistake right there. That was his only mistake right here. He thought that 3 inches was the base, which is not. All right. We look at the next one. Russell calculated the area of the triangle. He shows his work. It says that he's correct. It shows that he doesn't know how to explain it to his class. Okay, how would he explain it? He would say, I used base height times 1/2. It's the same thing as this one, right? Okay, they just put the half in front. It's the same. I use base and height times 2. My base is 43. My height is 7. Okay. Multiplied 43 times 7, and then divided that by 2. And that's how he got area equals 150.5 centimeters squared. All right. So you just have to write a previous explanation, something like that. There's variable answers to this. I saw everybody, and everybody did amazing on that. So congratulations on that. Okay. The last one. It's telling us that the larger triangle, which is this one, the one that's highlighted in black or has a black outline, has a base. So here's the base from this point to this point is 10.14. Okay, and the great triangle has an area. So they found the area of the great triangle for you. So what it's asking us to do in step 8, determine the area of the larger triangle. So it means this one, the one on the outside, and it has a height of 12.2. So if I was myself and help out myself, I would right away label it 12.2 meters. That's my height. Okay, so it's telling me to find the area of the bigger triangle. So I'm gonna do it right here. Base times height times 1/2. So the base is 10.14 times the height, which is 12.2 times 1/2. Put those all into a fraction. So now I gotta figure out how much is 10.14 times 12.2. So I'm gonna do it right here. Again, we need to practice multiplying decimals, okay? And let's do that. 4 times 2 is 8. 2 times 1 is 2. 2 times 0 is 0. And 2 times 1 is 2. Let's jump to the next one, 10th place. Again, 2 times 4 is 8. 2 times 1 is 2. 2 times 0 is 0. And 2 times 1 is 2. And the very last one now, this one is in the hundredths place. 4 times 1 is 4. 1 times 1 is 1. 1 times 0 is 0. And 1 times 1 is 1. And now we add. Bring down the 8. 8 plus 2 is 0. Carry the 1. 4 plus 2 is 6. Plus 1 is 7. 2 plus 1 is 3. 2 plus 0 is 2. Bring down the 1. How many numbers are after the decimals? There's 1, 2, 3 numbers. So I'm going to go 1, 2, 3. So now I have 123. Okay. 0.708. And I'm going to divide that by, so this one is 123. And divide that by 2. And that's going to tell us the area of the bigger triangle, the biggest one out of the 3. 2 goes into 12, 6 times, which is 12. Bring down the 3. It goes in 1 time. 2, 1. There's a decimal right there. Bring it up here. Bring down the 7. 2 goes into 7. 8 times. I'm sorry, into 17. 8 times, which is 16. Bring down the 0. 10 goes into 2 5 times. Bring down the 8. 2 goes into 8 4 times. 8, 0, no remainder. So the area of the biggest triangle, which is this one outlined in black, okay? So the area, so for letter A, okay, I'm gonna put an arrow right there. Area equals, for this one that I'm highlighting, the area of that one, which we did this, is 61.854 meters squared, okay? Here's the work, all right? If you wanna pause the video, okay? I'm gonna circle the answer. So that's the area of this one, the one that's you can see in solid black, the area of that entire triangle, okay? So we already know the area of the entire triangle on the outside. We know the area of the gray one. Now what to find on B, it's asking us what's the area of this white one here. What you're going to do is you're going to subtract this number from the number in gray, all right? So we're gonna subtract that. So we're gonna do 61.854 minus 40.325. And that's gonna let us know what's the area of that white triangle, right? So here we go. Last step. Okay, 6 minus 4 is 2. 8, 1 minus 0 is 1. Bring down the decimal. Okay. 8 minus 3 is 5. And before I do this, I notice that 4 is not greater than 5, so I'm going to need to borrow. Turn that into a 4 and this into a 14. 4 minus 2 is 2. And 14 minus 5 is 9. So the area of this small triangle is 21.529 meters squared. All right. Again, if you want to pause that, look at that. Okay. Follow those steps. Rewind the video if you need to. All right. That was lesson 4. It was kind of lengthy, but nothing that it's out of our reach. All right. So far, that's 4 lessons we've done. Okay. And now I'm going to jump and begin with lesson 5, which is the area of polygons through composition and decomposition. Like I told you guys earlier in virtual classroom, okay, I had most of you there, but I wanted to show you what polygons are, okay? Polygons are shapes that have more than 2 sides, all right? So for example, these are polygons. All right, there's thousands of examples of polygons, but these are all polygons starting from triangle because it has 3 sides, all the way to a decagon, which has 10 sides, an octagon, which has 8 sides, a pentagon, 5, and so on and so forth. All right, these are all different examples, like I'm mentioning of polygons. All right, stars. These are all polygons as well. All right, and these are all examples of non-polygons, all right? And these are 3D shapes, so if it's a 3D shape, it's not a polygon. It has to be a flat figure in a flat surface. So this, for example, this piece of paper right here is a polygon. Why? It has 4 sides on it, 1, 2, 3, 4. It's a 4-sided polygon, but if you were to see it in a 3D shape, kind of like a shoebox, like this book right here would not be a polygon. It is 4-sided, but if you look, all right, it's a 3D shape, so it doesn't qualify as one. It has to be in a flat surface. That's what makes polygons. All right, there's different examples. I would recommend you guys going into Google and just Google the word polygon and just play around with it, and you're gonna see all the different examples of polygons. There's irregular polygons like this shape right here. All right, we have complex, which are weird shaped polygons. All right, go into Google, just research polygons and you're gonna find some fascinating stuff on there. All right, so we're gonna work on these types of polygons. If you notice, it has 1, 2, 3, 4, 5, 6. So it's a 6-sided shape. It's a 6-sided polygon. All right, that's our focus for today, finding the areas on those ones. Going right away into this. Here's an aerial view of a woodlot. All right. So woodlot, imagine now with today's technology, you can go into Google, you can go into Google Earth. If you guys have ever jumped, and I just played jumped, if you ever been in an airplane or a helicopter, you can actually see from an aerial view, okay? And that's what it means, aerial view. You're able to see houses from all the way to the top. Now we have what are called drones, and you're able to film with drones. That's pretty legit. I want to show you an example, kind of how like aerial view looks like. All right, for example, this, okay? This is an example in aerial view. So basically, it's when you're seeing from the top, from the very top, okay, what you're seeing from air. Aerial means air. So what you're seeing from the top, looking at the bottom. Okay, so it's kind of like what a bird would look at. Okay, so this is what you're doing with aerial view. You're looking at this, all right? Just showing you an example of how this looks like, all right? And wanted to show you how it's so cool that when you're looking at into houses or anything, it'll show you the actual area of the house. So it's telling you in square feet. The size of this house is 896 square feet. All right, and the bigger the house is, the more you're going to pay. All right, just want to give you an example that connected into real life, how we use area all the time. All right, so let's jump into this. All right, remember that we worked with segments in the past. All right, for example, if I create a rectangle, okay, and this is A, B, C, and D, okay. This is segment BC. This is segment, or it could be segment CB. This could be segment DC or CD. This could be segment AD or DA, and so on and so forth. All right. So if this, for example, this is 5. This is also, you're thinking, okay, you didn't put anything, that's going to be 5. For example, this is 10. This is also going to be, okay, if you think about it, this is also going to be 10. This is also going to be 5. All right, they're parallel lines to each other, and parallel lines are equivalent. All right, just showing you a quick example. That's kind of what we're doing today. Okay, so we look at lines AB, which is line AB. It's 10 units. So the measurement from A to B or B to A is 10 units long. That's the measurement. Then we look at FE, which is from here to here. This is 8 units long. 8F, which is from here to here. This is 6 units. And DE, which is from here to here, is 7 units. All right. So what we need to find is the measurement, what it's asking us here. We need to find what's the distance between D and C, and we need to find what's the distance between B and C. All right, so I'm gonna get a blank piece of paper here and try to break this into pieces. All right, so imagine that I was to break this rectangle right here. It would look something like this. Okay, and if I was to break this one on the bottom, it would look something like that, right? If I was to actually separate them. Well, for right now, I'm going to use a red pen and I'm going to close those gaps, okay? With a red pen. I'm going to close those gaps, okay? So I know that AB, so I'm going to label them AB, okay? This one, F, and right here is E, okay? I'm following this on the top. So this one is E as well. This is D. This is C, okay? And this one is actually connected from top to bottom, so there's no point here, okay? I know that here on the top, this is 10 units. I'm going to use U. This is 6 units, okay? And this piece right here is 8. We don't know what's in red. Okay. This right here is 7 units. We don't know what's this. And we don't know what's this gigantic side. Okay. But this is just separating it. So what we're trying to do is we're trying to figure out how much is this space. So imagine that I was to bring like an elevator, this line right here, and I was to bring it and put it right there. All right. So I'm going to draw another one and now connect it. And what I'm trying to say is kind of looks like this, right? Kind of looks like that. All right. So this is 10 units and this is 8. We're trying to figure out, well, what's the distance between this point to the one I'm about to finish? How would you find that? There's 2 ways you can do that. You can do 10 minus 8. And that's going to let us know that it's 2. Okay. Or you can do the inverse, kind of like what we've been doing in the past. 8 plus x equals 10. All right. And some of you guys would tell me right away, oh, well, the missing number is 2. So if we do 8 plus 2 is 10, there's your answer right there. Some of you guys were doing it more algebraically and sending 8 to the other side of the equal sign. These cancel. 10 minus 8 is 2. So I'm just showing you different ways of how to figure this out, all right? Just different methods. But at the end, 8 plus 2 is 10, okay? So now I know if I cover this up, okay, you know that since this is 10, the bottom, which is this, is also going to be 10. 8 plus 2 is 10, all right? So the measurement for that one, okay, is going to be 2 units. Okay, and there we go. If we do 8, and again, we're going from left. You also, another clue is which direction they're going. You're either adding or subtracting going left or right. So this one's going from left to right, left to right. If you see the top is going left to right. So 8 plus 2 is 10. Imagine that I fill in the blank right there and now I have this. Okay, now to find BC, what I'm going to do is I'm going to add the ones going from up, down. So I have ED, which is going from top to bottom, is 7. We have AF, which is top to bottom. So AF is like around right here. This is AF. It stops right there. We know that that is 6 units, right? Look at the reflection, that's 6 units. And we know that this part right here is 7. So what we're going to do, we're going to add the 6 and the 7. And 6 plus 7 is 13 units. All right. So for this one, 2 units. And this one we said 13 units. Okay. Again, if you have any questions, let me know. Hopefully you're able to see that they're traveling the same distance. Like I pause here, rewind the video a few seconds and see that this part, if I block it, okay, this portion right here is also 6 units like on this side. But if I block the top, okay, this part right here that it's highlighted, okay, it's 7 units because this side is also 7, so it reflects. All right. So now the next problem is telling us just changing the numbers, getting us to practice. Now it's telling us that DC, which is this part right here, now DC is worth 10 units. So I'm going to use a different pen, okay, to not get confused. That's 10 units FE from here to here. Now they changed the worth and it's worth 30 units. Okay, then AF is 28 units this time. And the last one, BC, which is this gigantic line, is 54 units. All right, and when it wants us to find, AB, which is the distance from here to here. And it wants us to find DE, which is from here to here. All right, so how can we find what's the distance between A and B? Let's look for the lines that are going left to right or right to left. If we look at the first one, this is the first one that I spotted, left to right or right to left. This one's 30 units. So for the distance, so I'm going to show the reflection here on top. Okay, so from here to here, maybe yeah, from here to here, that's 30 units. And this missing spot, if we bring it up, from here to here is 10. So if we do 30 plus 10, that equals 40. So this spot right here, this new spot, I'm going to call it 40 units. All right. So AB is 40 units. And then DE, which is this one right here. All right. We're trying to find, now this one, we do the opposite. This entire line right here, which I'm now doing in red, is 54. And this one is 28. So what we're going to do with that 54 and that 28, we're going to subtract because we're trying to find, we already know that this spot, and I'm going to cut it just right here, that little cut. We know that from B to this little cut, it's 28 units. If you look right across the shape, it's letting us know that from A and F, it's 28 units. Okay? You see that there, if we connect them. So what I'm going to do is 54 minus 28. I'm going to borrow. It's 26 units. All right. So this right here is 26 units from E to D. All right. Or E to D. It doesn't matter. This could be AB or BA. It doesn't matter. But here you go. If you need to rewind it, rewind this video. All right. I hope that helped. All right. I'm going to skip this bottom part. The reason I'm going to skip this bottom part is because when I flip the next page, we're going to find 3 similar ones. And if I examine and analyze these, they're all the exact copy of each other. I see 2 2s, 2 2s, 2 2s. I see a 4 here, a 4, a 4. I see 9 9 9, 7 7. So they're the same. We just got to follow the directions of what it's asking us to do. All right. So I'm going to jump to that. Okay. And I'm going to read A, which is asking me on the first diagram. So I'm right here, which is this. I'm going to use this as my first diagram. On my first diagram, divide the stage into 3 rectangles using 2 horizontal lines. Okay. So I'm going to do 2 horizontal lines. There's 1 and there's 2 horizontal lines. Okay, 2 horizontal lines which create 3 rectangles. 1, 2, 3. Okay, so create 3 rectangles using 2 horizontal lines. We did that. Find the dimensions of these rectangles and calculate the area of each. Then find the total area of each stage. So we need to find the missing parts, just like what we did with this. Okay, we're gonna find, for example, we need to find what's this. We need to find what's this, and what's this. All right. Where we're gonna do that. So if I look at the first one and then find the area. So if I look at this, so if I know that this side is 4, I know that this also is going to be 4. If I know that this is 2, this is also going to be 2. I know if this is 4, they're the same rectangle, so this is also gonna be 4. This is also gonna be 4. If this is 2, this line right here is gonna be 2. Now if I look at this, okay, if I look at this bottom line, this entire line from this point to this point, which is being shared from here to here at 7, and this one we have 2 and 2, but we're trying to find this missing spot. What we're going to do is we can do 2 things. We can find the missing number. 2 plus 2 is 4. What number can give us to 7? Well, 4 plus 3 is 7. The other way we can do is add these 2 that we know for sure and subtract them from 7. So 2 plus 2 is 4. Now 7 minus 4 is, so you know that this spot right here is 3 meters. All right. And then the last one, from this point to right here, it's letting us know that it's 9 millimeters. But if you look at this spot from here to here is 4. So what I'm going to do with that 9 to 4 is subtract to find this. Okay. So 9 minus 4, so this spot is 5 meters. Now if you add the 5 plus 4 meters, that lets you know that this entire line right here, which I'm highlighting, is 9. All right. So this one, now we're doing the opposite. 9 minus 4, or we're doing across here, is 5 meters. All right. Before I continue with that one, I want to go ahead and follow what B is. I'm going to leave the area until the end. This one on the second diagram is telling us to divide the stage into 3 rectangles using 2 vertical lines. So now it's telling us to do vertical lines, which look like this. I'm sorry if it's a little bit sloppy. those are 2 vertical lines, and how many rectangles we have? 1, 2, 3. And I'm gonna do the same thing here. Now I know that this is 4, so right here this is gonna be 4. Okay, I know that the top is 2, so the bottom is also 2. That is 2. This is also 2. And we do the same thing here. If I know that's 2 and that's 2, but the whole thing is 7, I'm gonna do 7 minus 2, which is 5, and 5 minus 2 is, this is 3 meters. Okay. I know that this entire line from this point to this point is 9 meters. So I know that this one is also going to be 9 meters. All right. And if you want to go more extreme, okay, if you want to find out what's the distance between here and here, all you have to do is subtract this line from the entire one, which is 9 minus 4. And that lets you know that this line right here that I'm highlighting, it's 5. This one is also 5. All right. And then the last one is telling us to divide the stage into 3 rectangles using 1 horizontal line and 1 vertical. So I'm going to use 1 horizontal and 1 vertical. All right. And we have 3 triangles too. 1, 2, 3. Now I'm going to find and look at this. If this is 4, this is going to be 4. If that's 2, this is also 2. Okay. If this entire thing is 9, and we know that this portion right here is 4, okay, which I'm going to put right here again. To find out this spot, 4 to get to 9, 4 plus 5 gives you 9, all right? So this entire line here is as well 9, all right? So in here, now we know that this is also 5. I'm just reflecting, okay? And now with this one, if I want to find out what's the distance, so we know that this right here is worth 2, but we want to find out what's this that I'm doing dotted. 7 minus 2, okay, it's also 5. All right. So far, so good, people. All right. So we can go in and look for the area of each. Okay, so if I look at the first one, these are, it seems that these are the same. So for this one, I'm just gonna find the area for one of them and then add it to this one because they're the same. And on the bottom, so if I look at the first one, these are all, we're gonna use a formula base times height because we're working with rectangles. So we're gonna use base times height. So my measurements are, okay, if I look at this one, base times height, I'm going to do 2 times 4. Okay. 2 times 4. Okay. For this one, which is 8, I'm going to do this one, 2 times 4, which is 8. And I'm going to do the bottom one, and the measurements are 7 base times height, 7 times 5. Which is 35. And all I need to do now is I'll add them together. Okay. 35 plus 8 plus 8. Okay. 35 plus 8 is 43. And 43 plus 8 is 51 meters squared. So that's the area of the entire thing. The area for this one, I'm going to write it. It's here at the top. Is 8 meters squared. This is also 8 meters squared, and the bottom one is 35 meters squared. All right. If you want to rewind the video, rewind it. Okay. Go over it, pause it. I'm gonna jump to the next one. Find the area of the following ones. Okay. So this one, base times height. So I'm gonna do 2 times 9. Okay. This is my base, and I have it right here. Base 2. And my height, which is 9. Like, gives me 18. I'm going to do the same thing with this one. 2 times 9. They're equivalent, which is 18. And then I'm going to multiply this rectangle right here. Okay, which is 3. Here's my base. 3 times 5. Don't get confused with this one. 7 represents the entire line. Okay, I'm going to do 3 times 5. Oh. And now I'm gonna add them together, okay? 18 plus 18 plus 15. Well, I know that 18 plus 18 is 36 plus 15, 51 meters squared, okay? And then the last one, okay? Find the area of those ones, okay? So this is, it involves a little bit more. So I'm gonna do the first one, and I'm going to say, I'm gonna multiply this one, which is, I'm gonna do rectangle 1, which is 9 times 2, or 2 times 9, that's 18. I'm gonna work on the second one, which is, I'm gonna call this one second if I get, and that's 2 times 4, which is 8. And the last one, which is right here, I'm gonna do 5 times. Okay. And the last one, 5 times 5, all right? Which is 25, and I'm gonna add them together. I'm gonna erase this. 25 plus 8 plus 18. If I add 25 plus 8, that's 33. And 33 plus 18 is 51 meters squared. If you notice, why, Mr. Valencia, did we get all the time 51 meters squared? It's the same shape, you guys, right? It's this one right here without writing. It's the very same shape. It doesn't matter where you cut it from. You're always going to end with the same area. I just proved it to you, all right? And I forgot to write down the areas in here. This is 18 meters squared. This is also 18 meters squared. This is 15 meters squared. That's the area for that one. This one is also 18 meters squared. This is 8 meters squared. And the last one, this is 25 meters squared. Okay. Doesn't matter. Once we added, the area for this one was 51 meters squared. The area for this one was 51 meters squared. The area for this one was 51 meters squared. It's the same shape. It doesn't matter how you cut it. You're always going to end up with the same area. All right. If you have any questions on that, please let me know. Send me a message. All right. And I'm going to focus on D now. Okay. It's asking, think of this as a large rectangle with a piece removed. Okay. What are the dimensions of the large rectangle and the small rectangle? Okay. So the dimensions of the large rectangle, which is this one, think about it, the one on the outside. Imagine that you're not looking this on the middle. So imagine that this little rectangle, which is here, they took it out. Okay. So it kind of looks like that. And you have what's just on the outside. So what's on the outside is 9 times 7. Okay. That's the one for the big one. And for the small one, in order for us to know what it is, if you notice from here to here, according to the top, is 2, and from here to here is also 2. So we want to find out what's this spot right here, which in other words, what's this? Okay, what is it worth? So if you do 2 plus 2 is 4. 7 minus 4, this is going to be 3 meters. So you're going to do 4 times 3. Okay. Those are the dimensions. Okay. So it's like saying 9 meters times 7 meters. And this is like saying 4 meters times 3 meters. Those are the dimensions. All right. The next one, what are the areas of the 2 rectangles? Okay. The area of this one, 9 times 7 is 63 meters squared. And this one is 12 meters squared, right? What operation is needed to find the area of the original figure? Okay. What is the operation that is needed to find the area of the original figure? What we needed to do was subtract. Okay. What is the difference in the area between the 2 rectangles? So what we're going to do, that's why we subtract. we're going to subtract 63 meters squared minus 12 meters squared. Okay, and that equals to 51 meters squared. So again, we're working with the same one, just further proving to you in another method how to figure this one out. Okay. What do you notice about the answers for A, B, C, and D? The area is the same. 51 meters squared. Okay. So we're just proving that these four have the same area, which is 51, all right, meters squared. Okay, why do you think it's true? Okay. The reason why it's true, the shape never changed. Never change. Nor the dimensions. So they never change the number, nor the numbers. Okay? They use the same numbers all the time. Okay? If you need to pause this, all right? I know this is a very long lesson. I think we're almost finished with this. Okay, you got 2 more pages to go, like 1.5 to be honest, and then we're done. Okay, we're gonna look at example 2 again. At any point of this video, guys, if you need to rewind or pause it, and rewind and pause it, do it. All right, it's very helpful to rewind it. If you need to take breaks, you guys, during these videos, take breaks. Okay, attention span is really hard. It's really hard to sit down for an hour to watch a math video. I get it, it's really hard, but you know, watch 20 minutes of the video, take maybe a 5-minute break, go and then rewatch the next 20 minutes, take a break, then watch the rest of the video. And then if you need to rewatch it, go ahead. In some parts, if you're feeling confused, go back to that part and rewatch it, right? But I would recommend you guys taking breaks as you're watching the video so that your brain takes rest, your eyes rest, right? Your mind clears. All right, if you feel comfortable watching the entire video without taking a break, hey, you're a champ. All right, but I'm just giving you tips to help you out, just to stay calm and not get overwhelmed. All right, so maybe watch the front page of the video, pause it for a few minutes, a few seconds, you know, go drink some water, whatever you have to do to clear your head, then come back and continue, whatever works for you. All right, just giving you some tips. So I'm looking at this one, and it says decomposing polygons into rectangles and triangles. Parallelogram. So we have this is the parallelogram, A, B, C, D. All right, A, B, C, D is part of a large solar power collector. The base measures 6 meters, which is right here, and the height is 4 meters. All right. So the first thing it's asking us to do is draw a horizontal line connecting A to C. So I want to draw a horizontal line going like this. Find the area. So find the area of both triangles. So you're going to see why it's saying both triangles. So first of all, I'm going to collect a line from A to C. If it's a little scribbly, I'm sorry. I'm going to try my best to stay as straight as possible. I am holding a phone on my other hand. Okay, well, that wasn't bad. So now I have a triangle up here and I have a triangle here. All right. Find the areas of both triangles. So this is a triangle, ABC. Okay. So this is a triangle ABC. So I'm going to label that triangle 1, just for you guys know. This is triangle 1. And triangle ACD is triangle 2, which is this one right here, triangle 2. Just trying to help you guys as much as possible. That does not look like a 2. That's better. Okay. So now we're going to try to find the area of that. So in order for me to find the area, the next thing that I want you guys to do, okay, and it's very helpful, do this and connect them. Kind of trying to do like this right here. It's a right angle. And now I know that the height is 4 meters. So again, it's kind of what we've been doing here. If this is 2, this is going to be 2. If this is 7, the entire thing on top is on 7. So if this side is 4, the height is 4 meters, the height on this side is also going to be 4 meters. Same thing here. If the base here is 6 meters, here on top, even though I didn't write it, it's also 6 meters. All right. So I'm going to go ahead and write that already. Okay. So I know that the base for the top triangle is 6 meters. The base for the bottom triangle is also 6 meters. Okay. So it wants us to find the area. Okay. The first triangle. So we're going to use the formula base times height times 1/2. All right. So the base is 6 times the height is 4 times 1/2. I'm going to put them all in fractions. 6 times 4 is 24 over 2. All right. So the area for this triangle right here, this is not the triangle. The triangle is what's in gray. The triangle up here is 12 meters squared. I divided 24 by 2. 24 divided by 2 is 12. Okay. Now I'm going to find the area of this triangle. Okay. Same thing. I'm going to do base times height times 1/2. My base is 6 times the height, which is 4 times 1/2. Okay. I'm going to put those into fractions. And you notice that the numbers are going to come out the same. Okay. So it's 12 meters squared. So the area for this one is 12 meters squared. The area for this one is also 12 meters squared. All right. That's what we had to do on letter A. On letter B, okay, draw in the other diagonal, B and D. So it wants us to draw a line going this way. Find the area of both. Okay. So like I mentioned in the previous one, and I'm just going to draw the example here as close as I can. This is D, A, and I want you guys to do this as well. Practice is great. Okay. Now it wants us to do the line going from B to D. So it wants us to do this. Now it's going the opposite way. Again, this is still 6. And we have this on the outside, which is 4 meters. And if I do this one as well, this is also 4 meters. This is also going to be 6. So if you notice, I'm going to do the same thing. Base times height. So 6 times 4 times 1/2, which is 24 over 2, 12 meters. I'm going to do the same thing for, this is triangle 1. I'm going to do the same thing for, I already found the area for this one. This is 12 meters squared. Now I'm going to find for triangle 2. Same thing, it's 6 times 4 times 1/2. Make them into fractions, which is 24 over 2. So the area of the other triangle is also 12 meters squared. So if you notice, it's kind of like the ones we did here, where we mentioned that all of them, their area was 51 meters squared. All right. 1, 2, 3, 4. They all had the area of 51 meters squared. If you look at right there, same thing for this one, 51 meters squared. This applies to this one as well. It doesn't matter how you cut it. The area for the triangles inside doesn't matter if you cut it this diagonal way or this diagonal way. You notice that that's 12 meters squared, that's 12 meters squared, that's 12 meters squared, that's 12 meters squared. All right. I hope that helped. Okay. I definitely hope that helped. And we're one problem away from finishing the lesson. All right. Now we have this. Again, if you have any questions, let me know. Send me a message through Class Dojo email. Rewind the video if you need to look at it. All right, take some pauses. All right, rest your brain. I would rewind the video and look at it if you need any clarification or if I'm talking too fast. All right, I just don't want to make the videos extremely long. We look at the next one. Example 3, decomposing trapezoids. So this right here is a trapezoid. All right. It's a polygon. It's a 4-sided shape. 1, 2, 3, 4. The trapezoid below is a scale drawing of a garden plot. Okay, so imagine you're kind of looking at a garden from an aerial view again. And then we have find the area of both triangles. So we have triangle ABC. Okay, but in order to do that, okay, we're gonna need to cut it, all right? Right now we don't have a triangle, so we're gonna have to cut it to make it triangles, okay? So it's giving you, this is the hint right here, even though there's no triangles, okay? Find the area of both triangles A, B, and C, so it has to be A, B, and C. So I'm gonna connect it like this. So now you have a triangle A, B, and C, and then you have A, C, and D, all right? So I'm gonna label this triangle 1, and the ACD is triangle 2. Find the areas, okay? So we're gonna use base times height times 1/2. So the base, okay, the base for this one is 8 meters. Sorry, I'm trying to get it to focus. I'm gonna use base times height times 1/2. So I'm gonna do triangle 1 first. The base is 8. Times the height is 5 times 1/2. Okay, base 8, height 5, base times height. 8 times 5 is 40. 1 times 1 and 2. So 40 divided by 2 is 20 meters squared. So the area for this triangle is 20 meters squared, okay? And now we look at the top one, okay? And that's our next focus. And we're gonna focus on that triangle, okay? Remember, they're reflections of each other. So imagine that I kind of do right here. Imagine right here that I'm showing the area, okay? And if this is 5 meters, this is also going to be 5 meters, all right? So I'm gonna do base times height. Now the base for this one is 4. So I'm gonna do 4 times the height. And it's also showing it here. You can also use this one if you don't wanna get confused, okay? Because at the end, the height is from top to bottom times 1/2. I'm gonna make them into fractions and then go across. That's 20, 5 times 4, 20. This is 2. So the area for that one is 20 meters. I'm sorry, 10 meters squared. So the area for this one, okay, is 10 meters squared, okay? Now it's telling us to find the area of the trapezoid. So what I'm gonna do is add these two, 20 plus 30. So the area of the entire shape on the outside is 30 meters squared. That's your final answer. Okay. So far, so good. And then on this one, I'm gonna redraw it again because now it's telling us to change how we do the diagonal line. I'm gonna try to do it as best as I can. And you guys have to do this as well. This is A, D, C, B. And then it's telling us to find the area of these triangles ABD. So it's ABD. So I'm gonna do a line right here. So now I have ABD. I'm gonna call it that one, which is 1, and then BCD. BCD. Okay, that's triangle 2. Okay, find the area. So I know that the bottom one, this is 8 meters, okay? This right here on the top, I'm getting the numbers from here, is 4 meters. And I know that the height from here to here, this is 5. I can't remember correctly. It's 5, yes. And from here to here is also 5, all right? So now what I'm gonna do is multiply base times height. I'm gonna begin with the first triangle. and I'm gonna do it right here. 8 times 5 times 1/2, which is right here. This is the base, okay? And this, I can use this height or this one, it doesn't matter. 8 times 5, base times height, which is 40/2, and I get 20 meters squared. Now I'm gonna do the other one, which is 4 times 5, base times height. That's the base of triangle 2, and the height is 5 times 1/2, which is 20/2, and I get 10 meters. If I add the 20 meters squared and the 10 meters squared, that's gonna let me know that the area of this trapezoid is 30 meters squared. I'm gonna circle it, okay? How else can we find this area? There's different methods that you can do it, all right? You can cut it in half. There's different ways, but I'm trying to show you and demonstrate you. It doesn't matter how you cut it. The area is always come out being the same because it's always the same shape with the same numbers: 4, 4, 5, 5, 8, 8. All right, and that is today's lesson. All right, that is today's lesson. That was page 21, if I'm correct. Okay, so your homework, our pages here is at the bottom: 22, 23, and 24. Just want to explain a little bit what my expectations are you guys for this, right? So for this one is what we did at the beginning. Make sure you label the measurements and try to find the missing measurements, okay? And then find their area, okay? For this one as well, okay? Determine the area of the trapezoid. So what you're gonna try to find is find the area of the triangles and then add them together. Okay, and same thing for this one. Find the area of the triangles, and then that should let you know. This one is a very close example to what I just did with these trapezoids. With this one, it's asking that they want to paint this house. So the first thing that you have to do is you have to find the area of this window, the area of this window, the area of the door, the area of the wall. They're only gonna paint the wall. So once you find the area of these two windows and the door, you're gonna add the area of these two windows plus the door, and you're gonna subtract it from the entire area. All right, probably gonna have to send some people some video on that one just to clarify it. Okay, and then this one, follow the directions. All right, very closely. If you look at from this point to this point is 45. You know that this one plus this one, 10 plus 35 is 45. So this is 45. If you look at this side is 35. And here, if you notice, this is 20 and this is 15. 15 plus 20 is 35. So this entire side is also 35. All right. If you have any questions, let me know, you guys. Sorry about that. If you have, again, through Class Dojo or email, I will be sending the lesson to the people that ask me, right? We're finishing with this lesson this week. Hopefully by next week we begin using Edge Elastic. I'll send you more info during the weekend. Again, watch this video. This probably has been the more complex lesson, but I know you guys got this. You're understanding how to find the area of triangles, base times height times 1/2. Look at this video very carefully, okay? If you need to rewind it, okay? Again, take pauses if you need to. Okay, and again, if you have any questions, let me know. I'm here to help. You guys know I love teaching. I love you guys. Take care of yourselves. Have a good one.